Here's the graph of f, and here's a graph of g. And we're told that the equation for the function g of x could be found by taking the equation for f of x and multiplying by a constant, which graphically would be a vertical stretch. So since that's the only transformation being imposed, we need only compare a couple points and determine the value of a, meaning what is the factor that's being used to vertically stretch the red graph into the blue graph. Looking at this notation, it may be helpful to remember that the notation g of x represents the output of g, and that the notation f of x represents the output of the function f. Once you understand that notation, you realize that we're saying that to get an output of g of x, we need only take an output of f of x and multiply by some constant. Notice that the input variable x is the same in both places. What this means, if we take a point on f, let's say the high point here of 2, 1, we can find where that point gets mapped to on g of x by leaving the x value alone and see what the output was multiplied by on f to get the output of g. So for example, since I picked a point, and I could have picked any, but I picked this one out of convenience, I picked a point whose x value is 2. Since I'm not changing the x value in my example, I would find the point on g that has an x value of 2, and that would be right here at 2, 3. So notice I'm picking 2 points with the same x value, and this notation says that the output of g is obtained by taking the output of f and simply multiplying by a constant. So let's write down what our output of g is and what our output of f is. So looking at both graphs for x equals 2, the output of g when x is 2, the function value is 3 when x is 2. So that means the output of g is the number 3. And we're told that's equal to some number a times the output of f. So what is the function value of f, or the output of f, when x is 2? Well, when x is 2, the output of f of x is 1. So I have an equation that says 1 times a equals 3. Since it's just 1 times a, there really is no need to solve. Had this number come out to be something different, obviously we'd have to divide that number on both sides to solve for a. So for this example, a comes out to be 3. Since a is 3, this means that to get any output of g, you could take any output of f and multiply it by 3 as long as you're keeping the x values the same. So for example, to show you this equation works, suppose I picked a point right here at 3, -1. We're in the business of leaving the x value alone, multiplying the output by 3. So if I left the x value alone, that would be x equals 3 over here. The formula says to find the output of g when x is 3, I simply take the output of f and multiply by 3. Well, my output of f is right here at -1, and if I multiply -1 by 3, I get that when x is 3, the function value for g would be 3 times -1 or -3, and that indeed shows up on my graph. This is the point 3, -3 right here. So this equation shows me how to get from any point on f to its transformed point on g. Notice that the x-intercept stayed the same. Let me show you why that happens. For example, here's the point 1, 0. If I leave the x value alone, that would be 1. This equation says take the output of f and multiply by 3 to get the output of g. Well, my output of f here, when x is 1, is 0. So this equation says when x is 1, the output of f is 0. Says it right here. So to get the output of g when x is 1, we take the output of f, which was 0, multiply by 3, and we get that g of x would be 3 times 0, or just 0 here. So it predicts when x is 1, the output of g of x would be 0, and that's right here. Looks like I color-coded my point wrong, but you get the idea. 1, 0 stayed 1, 0 when we transformed the function, because all we're doing is taking the output of each point and multiplying by 3. 0 times 3 is 0. 1 times 3 is 3. And -1 times 3 is -3. I'm going to do one more quick example, just to be thorough. This is an example for which you will find the value of a is negative. The reason I can tell just looking at the graphs is if you look at the red graph and the blue graph, The shape is the same, except this looks like an upside down V, and this looks like a regular V. So what happened here is this graph of f was reflected about the x-axis, and the rule for reflecting a graph about the x-axis looks like this. If I want to take a function f and reflect it about the x-axis to produce the graph of g, one must multiply by a negative number on the outside of the function as shown here. Just putting a negative on the outside of the equation for f of x will take the graph of f and flip it upside down relative to the x-axis to form the function g. What this means in my example is that a is just going to come out to be a negative number. But the actual way to do the problem is no different than my previous examples in this video. So for example, let's pick an x value. I'll choose this one, x equals 2. At x equals 2, the y value is 1. This equation says that if I want to find an output of any point on g, I simply pick an x value. I chose x to be 2. And for x equals 2, the y value, or the output of f of x, is 1. So this notation here, which represents the output of the function f, would be the number 1. Now I must find the output of the function g for when x equals 2. Well, the graph over here shows that when x is 2, the y-coordinate is over here at negative 3. So where I have the notation g of x here, I can replace all of this notation g of x by saying for x equals 2, the output of g is negative 3. So I'm replacing g of x with negative 3, and I get the equation that 1 times a is equal to negative 3. So again, there's no need to solve for a. I simply get a is negative 3, which answers the question. You can take any point on f, find where it gets mapped to on g, by simply taking the output and multiplying by negative 3. 1 multiplied by negative 3 is indeed negative 3, and this would work for any point on f. The rule is, though, that you're keeping the x value the same. Notice I'm comparing this point whose x value is 2 to this point whose x value is 2. If you want one more quick example, notice the point right here at 1, negative 2. If I didn't even have a graph and I was asked to draw a graph, I would say, oh, on g of x, we're leaving the x value alone, or just keeping it, and the output of g can be found by multiplying the output of f by negative 3. So remember what this statement means, that if I want to find the output of g of x, since we found the value of a for this problem to be negative 3, to find the output of g, I can simply take the output of f and multiply by negative 3. For this x value, when x is 1, the output, f of x, is negative 2. So when x is 1, the output of f comes out to be negative 2. I'm replacing all of this notation here with the number negative 2, and it predicts that when x is 1, I wrote x equals 1 here, the output of g is negative 3 times negative 2, or positive 6. And if you look at the graph of g over here, 1, 6 is indeed on the graph. 1, 6 is right here. So this point here got mapped to this point here on g.